Hello everyone and welcome to my lecture on SNI reaction. In the earlier videos, we have discussed in details SN1 and SN2 reaction mechanism. Let's have a quick recap at SN1 and SN2 reaction mechanism. SN1 reaction is a two-step process leading to the formation of carbocationic intermediate, which finally leads to the product. The rate of the reaction is only dependent on the concentration of the substrate, and therefore the reaction is called first order reaction. SN1 reaction gives a racemic mixture, and the rate of the reaction is of the order tertiary greater than secondary greater than primary. Whereas in SN2 reaction, the reaction is a one-step process, proceeds through the formation of transition state. The rate of the reaction is dependent on the concentration of the substrate and nucleophile. Therefore, the reaction is second order, and SN2 reaction leads to inversion of configuration. The rate of the reaction is primary greater than secondary greater than tertiary. Now we will discuss about a new reaction mechanism, SNI, substitution nucleophilic intramolecular. When secondary alcohols are treated with thionyl chloride, we get alkyl halides. It undergoes substitution with retention of configuration. If the alcohol is of R configuration, the product is R, and if the alcohol is of S configuration, the product is S. The rate of the reaction is dependent on both the concentration of alcohol and thionyl chloride, and hence the reaction obeys second order rate equation. But why did the reaction proceed with the retention of configuration? To understand this, we have to look into the reaction mechanism. First, the secondary alcohol reacts with thionyl chloride to give the intermediate alkyl chlorosulfide with the elimination of HCl. Since the bond attached to the chiral carbon is not broken while formation of the intermediate, the alkyl chlorosulfide has the same configuration as that of the alcohol. Further, the intermediate breaks down into the ion pair pH MeCH plus and SO2Cl minus. SO2Cl minus further dissociates into sulfur dioxide, a neutral molecule, and Cl minus, which will now act as a nucleophile. Now the question is, from where will this nucleophile attack? Will it attack from this side, or it will attack from the back, leading to SN2 reaction? It is preferable for the nucleophile to attack the carbocationic center from the side from where it is forming rather than from the back as in SN2 reaction. Since the nucleophile attacks from the side from where it is formed, so it obviously leads to retention of configuration, and therefore the entire reaction goes via a new reaction mechanism, that is SNI mechanism. For your convenience, the entire discussion is written here point-wise. Now I will discuss another condition. When the same reaction is carried out in pyridine, the observation is different. In the presence of pyridine, the product obtained is found to undergo inversion of configuration. If the alcohol is R configuration, the product is S, and if the alcohol is of S configuration, the product is R. To understand this, one has to again look into the mechanism of the reaction. The first step for the reaction in pyridine is same as the earlier reaction. Alcohol reacts with thionyl chloride to give alkyl chlorosulfite intermediate and HCl. Now here, since the medium, the reaction is carried out in pyridine, pyridine acts as a solvent and a base. Since it acts as a base, it reacts with HCl to form pyridinium salt and chloride ion. It is this chloride ion which now acts as a nucleophile. And in this chloride ion, the difference here is this chloride ion is present throughout the reaction mixture. Now the question lies again whether the nucleophile will attack from this side. From where will the nucleophile attack from? Will it attack from this side or it will attack from this side? If it attacks from this side, then there will be an inversion of configuration, and if the chloride attacks from this side, then there will be a retention of configuration. Now, to avoid repulsion between the nucleophile and the leaving group, as they are both of same charges, so it is preferable for the nucleophile to attack the chiral carbon from the side opposite to which the leaving group is leaving. Therefore, this will lead to the formation of a transition state and finally to a product with inversion of configuration. Therefore, you can see that with the change in medium, the reaction mechanism changes from SNI to SN2. Again, for your convenience, the entire discussion is written here point-wise. That's all for today. If you like my video, please subscribe, like, share and comment. Thank you and bye-bye.